Hello everyone and welcome to the last edition of this data analysis training on R programming. Today we're talking about time series analysis. And what is time series analysis? Time series analysis is a way to predict future occurrences over time. So for example, you can look at this humidity across time per year chart. You can use this past data set to try to forecast future humidity values across time by year. So that's basically what time series does. And for you to conduct a time series analysis, you need to have some packages installed, some exploratory data analysis and discrete data analysis conducted, some data cleaning, and then finally your arima model, like your model type, your evaluation matrices, and then finally the forecasting model. So we'll be making this video in two sections. We'll be talking about the exploratory data analysis, the descriptive analysis, the data cleaning, the fitting of the model, the evaluation metrics. But when it comes to the yearly forecast, I'm going to make a separate video and I'm going to explain why in another section of this data analysis training. So I'll be explaining this code one by one because if I start coding it across the video, it's going to take a lot of while for me to finish, and I don't want to make this video so long. So moving on, first of all, we're going to import our data sets, and we're going to be importing the train data sets and since the CSV file. I've already imported this before, I'm just showing us how to do it. I'm going to send us this file as well. So browse and then go to where the data set is. Then is it archive 39? Yeah, archive 39. Then click on train. Then when you've imported it, when you've imported the data set, then check for the class. This basically yeah. Then after you've done, so basically test if the data frame. Then after you've already done that, then try to rename the data because I don't like this data set name because it makes it so complicated to if I want to write my code or reference the data set, I will not be writing daily climate strain. I don't want to do that. And by the way, this data set is gotten from cargo, and if I want to get the data set information, I'm going to show us in a bit. Okay, so okay, so my recording app doesn't really allow it. So I'm going to send a screenshot, or better still a link to the cargo data set so you can actually go and look at data set. So I'm going to just talk briefly about it. So the data set is fully dedicated to the developers who want to train the model on weather forecasting in Indian. As you can see, the data set is about daily state or something. So you can see it's an Indian city, Indian country rather. The country is in Indian, is in India. Sorry, the dataset provides data from 1st of January 2013 to 24th of April 2017 in the city of Delhi, Indian. Okay, the four parameters are mean time, humidity, wind speed, and mean pressure. And the dataset was collected from weather undergrouped API. The dataset owned and credited goes to them. So, and we've talked about everything we need to know. So moving on, and since we're working on a time series analysis, you have to install our packages like I've said earlier. So after I've already renamed this data set to time series underscore train, because okay, yeah, I'll explain in the later videos, but just name it this way. Then look at the structure of our data set. So to do that, just before we do that, we have to install and load this tidyverse package and this deploy R, because they are both responsible for data manipulation. So to do that, just load this. And since I loaded this before, it's actually not will not load. But another thing I need us to note is that we need to have our internet connection on when installing and loading our package. Is very important because it's basically downloading some informations that we need. Then install this deploy R as well and load basically. Then ggplot for visualization and forecasts if you want to for future values, and if you want to run our time series analysis. Okay, so after we've done that, you can now check the structure of our data sets. As you can see, date is in date, mean time is in numeric, the remaining ones are in numeric. This here is a new column generated by me actually in the latter stage of this video, and I'm going to explain why as well. Then another thing I did is to convert them dates to a time series data type. So but before I did that, I actually did a summary. This is basically the descriptive statistics. So descriptive statistics. So at least there is no way we want to conduct analysis and not try to examine the data set. What is the average humidity value? What is the minimum humidity? What is the maximum humidity? So those informations are actually necessary for us to proceed with the data analysis, because it gives us the preview of our data sets. So summary, as you can see, the minimum mean time is 6, and the first quarter is 80.86. That's a median of 27.71, a maximum value of 38.71, as well as the wind speed and the remaining ones. The next thing I did was to convert this to a time series data type, which I did here. Then another thing I did was to install something called lubricants. So it's actually this before this, basically. So it was when I was running the code and I realized the code wasn't actually running when I was doing it on my own, basically. Then I discovered that I haven't installed this package called lubricant. Then I did. So okay, since I've installed it, basically I don't need to install it again, just have to load it. Then I did this. Right now, here comes our data visualization. This particular one is basically for trend, to discover trend. Now this particular one is basically on okay, no, not trend, it's basically to examine the distribution of our data set. So distribution of our data, yeah, let's put it that way. So the first one, they are basically an histogram, sorry, to discover the distribution of the mean time, the average, the mean time, the humidity, and the third one, which is the wind speed. So like I've always done is we are going to use a pipe operator after the variable, then ggplot, then AS x equals to mean time. Since we only have one variable that we're using, you don't really need to specify the y variable. So x equals to mean time, then zoom underscore histogram, the width size, then the color is red obviously, and the labels. So when we run this variable, we get an histogram obviously of the mean temperature. Actually, since you're only dealing with the mean temperature, like our forecast is basically on mean temperature, that's why I only did for mean temperature actually. But if you want to do for wind speed, you can actually do it as well, just to avoid to avoid a lot of stress. I'll just decide to copy this, and instead of mean time, I'll use wind temperature. So wind speed, sorry, then this is going to be wind speed. And instead of I can actually use distribution of wind speed basically, but let's use histogram of wind speed. So let's check. Yes, you can see it's basically skewed to the left and it's not normally distributed. But since they're working on time series, there's nothing like there will be nothing like outlier, because each one of them is an observation across time, and each and every one of our observation will be needed. So we're not removing any of our values. Then we move on to the trend analysis. So we are going to check the trend across time, because we are dealing with time series analysis obviously. So since we are dealing with time series analysis, we have to also discover the trend across time. So across each and every one of our variables, from the mean temperature to the wind speed. So that's why I did this. And that's I need us to know about ggplot is that, as you can see earlier, that's okay. I feel I should give us the original raw data sets before I clean it and added a year colon to it, so you can better understand what I'm trying to say. That I included a year variable after So you can see that there is no year value to it. And if you look at this time series, there is already a year colon attached to it. I will show you. I've already told us why I did it, but I will also show us when I did it. So okay. So another thing I want us to know is that in ggplot, when using ggplot and you specified year as a factor, and even if you don't have a year value, a year colon in your data set, it's still going to run. So then this one is basically the trend of mean temperature across time, across years. Sorry. So as you can see, it's basically repeating the same cycle across each year. So you can see that each of these single line represents daily values across the years. So this red bar represents all the daily mean temperature, all the daily mean temperature across 2013, across 2014, 2015, and 2016 respectively. 2017, nothing really happened in 2017 because there is little to no data set of 2027 and 2017. So that is why it couldn't really discover a bar to it attached to it. So I did for humidity as well, and I did for as you can see they're basically repeating the same cycle, and I did for train and for wind speed. Sorry. And I want us to note about this wind speed is that although they're actually repeating the same cycle, but they're actually lower. The wind speed is actually not really that high across the years, and you can see they're repeating the same pattern. So another thing I want us to note is the seasonal direction. This seasonality detection is basically for you can as this seasonality detection is basically also viewed towards through this line charts. So both the trend analysis and the seasonality detection has been done using this line chart. So one thing I want us to note here is the scatter plot matrix. And remember, these are all exploratory data analysis. So our main goal is to forecast and develop a model. But before we do that, we have to examine our data sets, which we are actually doing currently, and it's called exploratory data analysis. So scatter plot matrix, to be able to do a scatter plot matrix, we need to install a package called ggre. So I've already installed it as well, so I'm going to load it. Yeah, and it's telling us that gg package was built in around that version 4.52. It's not really a big deal, so whenever I see this error, yeah, basically you have to ignore it. So and okay. So I'm trying to reinstall it basically. And sometimes it brings an error message that it cannot install. When it brings an error message when you're trying to install your package, basically what you have to do is just to reinstall it until it actually happens. And probably this error message is due to the fact that I've actually installed this before. So, but that way. So when it's installed, you're going to know basically because it's going to tell you that it's successfully installed. Then for me to conduct the scatter plots that actually segments or groups my data sets data sets by year, I have to create a data set a year colon which I actually introduced in this segment this particular year. So to do that, what I just had to do was to use the mutate function and the pipe operator as well. So times series string is equals to times series pipe operator, then mutate year is equals to year date. So it basically brings out the year of each of these dates. It basically brings out the year of okay, yeah, this date basically it brings it out and gives me the value. So you can see the difference between these two data sets. Oh, sorry. This is basically the test, and this is the train. Oh, these two are two different. This one is basically 2013 to 2017. This one is the test. So I'm going to import the. Okay, so I'm going to, you know, I'm going to do something. I went to view the test version instead of the training version. So I'm going to go back to the line of the code that I imputed it. But since it's hard to find okay. Yeah, so this is it. I went to view the test instead. It should be the train, so not the yeah. So I want us to view the changes that I made in the yeah. So this is the train. Okay, I don't need this one for now. Yeah, so this is the train version. You can see the changes that I made. I added the year colon to this, which is not there. So basically what he did is extracted the year 2013, extracted it and put the new colon as a year. Yeah, so moving on, I'm going to cancel this, so it's not going to affect my future codes. Okay, so I've already installed the package called ggli and I've created my own year basically. Then now I'm going to create a scatter plot matrix between humidity and temperature, so and across here. So the reason why I did across here was to basically have a more granularity. And since 2017, like I said in our train data set, 2017 was not really included in our data set. So basically some few observations were added to the 2017. So that's why it's not really it's not really our focus basically. We're not really focusing on 2017, we're focusing on 2013 to 2016. So and you can see similarly they have the same correlation pattern. As you can see, look at if you look at my the way I'm opening the mouse, you can see they have the same pattern. Yes, moving on, I'll do for the remaining ones of them as well, between temperature and wind speed. And you can see they also follow the same correlation pattern as well. Then another thing I want to do is to summarize mean temperature. Since mean temperature is our focus, I want to summarize it to an average value instead. Then basically I created a time series object. So this three parts is basically used because I want to conduct the I want to start conducting the forecast basically. So I had to like train the model across like since I'm dealing with mean temperature, I have to turn the mean temperature to an average value, and that's why I said the mean of mean temperature. Then I had to create my time series object. Then I'll fit my forecast model. Yeah, so moving on to this, basically what this is trying to tell us is that no autoregressive terms. And basically what it's trying to say is that yearly mean temperature behaves like a constant average with random fluctuations rather than a strong up and downward movement. So and you can see also that in the same arima model it also got a mean of 2.22.4, which is the estimated average mean, every estimated long-term average yearly temperature. And also we got the standard error, and then we got our evaluation metrics. So AIC of 36.53, which is basically talking about the, and you can see earlier we can see we got an arima of 0,0,0 which is 0 mean. So since it has the lowest quality and obviously it is the only one, it was selected, And so what it does is basically to test for the best model fit. So AIC, which is 35.53, indicates that it is low basically, but um it's only meaningful when you want to compare multiple models on the same data. So it's not really not really useful. Like, it's not that it's not really useful, but I'm not really going to be using that one. So then move to the corrected one. AICC basically. Okay, yeah. Yeah, AICC, which is 42.53. So since we have small sample size, we're going to be going with AICC. So I want just to go and make our research on this goodness of fit test as well. Then yeah, so that's where we stop in this video. That's where we stop in this video. The next video we're talking about the test model where we actually try to run the forecast across each year, like the yearly forecast. So I believe you understand so far. So thank you very much for watching. And if you have any question, you can reach out to me. So do have a nice day.